Sriram, you are able to hear me, right?
Yeah, I'm able to hear you.
Yes. Okay. Yeah. Yeah. So yesterday we started discussing on window functions. So we have seen how we can use window functions in terms of ranking. Rank, dense rank, and row number. We have discussed those points. So based on whoever partition by, order by. So with these clauses, we can be able to achieve this ranking, maybe within some group by columns or without grouping. So for the entire data set, for the entire table, we have seen those things. So to continue with that window functions, we have two more functionalities where we can use this window functions. So those are analytical functions and as well as aggregate functions. So we'll start with these two today. And yeah, analytical functions, basically we have two analytical functions which are available for us. Those are lead and lag functions. Okay, so lead and lag, basically, suppose you have a scenario. Suppose you have say a scenario like what is the total price of each product? So product wise, what is the total price? So if you want to do that, what we need to do, we need to do product ID and then maybe sum of line total. Okay, and then you need to give a group by product ID. Okay, so if you want to do that, we can achieve that. But my requirement is sometimes, right? So apart from product ID, I want other columns as well. So I want to see other columns from my table as well. So if that is the case, obviously we'll get this error message because so if we are using group by and if we are writing such kind of logic, we will not be able to see the other columns, right? So if that is the scenario, so in those cases, we can be able to achieve this through this aggregate functions and analytical functions. But this we'll see later. This comes under aggregate functions. But for now, what I will do is I want to this will comes under aggregate functions. Let me take this later. So when you see this, right, I want to compare previous record with the current record. Okay, so if that is the scenario, so current record to previous record and previous record to current record, so something like that. So if that is the case, then you can be able to do that using this lead and lag functions. Lead and lag functions. Okay. Yeah. So what this lead and lag? Okay. Suppose I want to see the difference between, or I want to compare my current record with previous record or previous record with current record. The very common use case for this is, suppose I have a sales table. Actually, this table is not having proper information. Maybe I'm having a sales data. So where I'm having the sales information like sales ID, maybe product, and then region, month, or date, whatever it is, right? So month, and then something amount. Okay, so I'm having something like this. So now what I need to do is I want to calculate the difference in or compare month-wise sales. Compare month-wise sales. So meaning maybe in the month of January, I'm having something maybe 2 million, and then in February it is 3 million. So something like that, so on. So I want to compare what is the difference from previous month to current month. So here I want to add one more column, something like difference. Okay, so then I have to maintain this as 1 million or maybe some 50% increase. Okay, so likewise, if you want to do that you can do by using this lead and lag functions. Why? Because if you see any SQL query, what you are writing, so that will execute record by record. So when you are writing something, select star or where condition or whatever it is, right? So this will look for this particular record and whatever the logic you are writing. So the scope, when you are executing this will consider your first record and it will execute, and that will take you to the output. So then second record, then third record. So likewise, now in this scenario, our intention is I need to take my previous record and I need to capture this previous record data and I need to compare current record. So that you can do by using this lead and lag functions. Okay. So here lag is, it takes previous record, okay, into consideration. Similarly, lead will be next record. Okay, very simple, normal English words, right? Lagging meaning behind. So that means previous record. Leading, so next record. Okay, so how to use this, we'll see now. Okay, maybe this data is not appropriate to make use of this. Maybe I'll get it the data from ChatGPT. Okay. Somebody have to go to mute. Naresh. Okay, I'm muted. Okay, I'll go to ChatGPT. Give me a table, create statement, and data to practice lead and lag functions in SQL along with data. Consider maybe sales data, region wise and month wise. Yeah, sales data table got created with ID, region, sales month, and sales amount. And this is the data which we can insert into the table. Sales underscore data. Okay, so I have inserted the data into this, and now if I see select star from sales underscore data, so I could see some data over here. So region wise and month wise and sales amount. So now I want to see the data of the previous record, right? So here, if you see, this is my first record, this is my second record, something like that. So our intention, my previous sales amount, I should see over here in my second record. So that you can do by using something like this. Lag is a function which takes your previous record to current record, right? So what record, what column value you are expecting? I'm expecting sales amount. So sales amount lag of sales amount. And again, since it is a window function, obviously we will be using this over class over. Maybe I'll say order by month. I'm just using order by month for now. I'm not using any partition by. So what is that partition by? We'll see. So order by month, and I will give some alias name as previous sales amount. Okay. Invalid column name month. Sales month. Sales underscore amount, sales underscore month. So you can just select this and you can run this. Okay, so if you see your data now, so based on the month wise, we have done this order by, and then this previous sales amount we are seeing like this. So if you see north, south, east, west, so something like this. Okay, so forget about this. We'll see what is this later. But for now, the previous amount we are capturing over here. Okay, so if I want to see the difference between this and this, then what you can do, again, you can do something like sales amount. Maybe I'll use sales amount minus. Okay, so what I did, I've just used the sales amount minus the same thing, whatever I have used over here, and I've named it as diff, and I've used sales data. Okay, so the same thing, what you can do, you can write in some with statement with CTE as, then shall start from this one, from sales data, and I can say select star comma, maybe self star comma, and what is this sales amount minus previous sales amount from CTE. Okay, so if you see here, right, maybe since it is a simple query, so we are using this lag of sales amount, this one, 2 times, because it's not a calculated earlier, right? We are calculating this as part of your self statement, so you have to write it 2 times. Okay, so if you convert this into with statement, say commentable expression, right? You can write your logic over here, and from there you can do whatever you want. So that is how you are making and you are working on your CTE. Okay, so from here you can understand. No column name. Okay, I'll give as diff here. City. If this is intended to be a comment or expression, you need to express in terminal creation. That is important. Oh, okay. Yeah. So I just gave alias name. So like this, you can be able to write your lead. This is lag, right? So similarly, if you want to do that lead, okay. So I'll write this same thing here, like lead. Next sales amount. So if you see here, next sales amount. So this record will be captured into your previous record. So 8,000 will come here, 15,000 comes here. So likewise, so your last record will be having null here. Why? Because there's no next record to this. So similarly for lag, so the first record will be having null and then the next record will be having the previous record values. Okay, so that is how you can get it and you will be having this. Okay, so suppose the same thing, sales month is okay, but I want to do this region wise. So region wise, I want to see what is the sales month and sales amount and what is the difference and what is the difference percentage or something like that. I want to calculate that. So if that is the case, what you need to do is you need to use partition by. Partition by will give you the grouping, right? So partition by region, I want to calculate and I want to compare with previous record and current record, something like that, and I need to do that. So if you see here, east, and 8,000, 5,000, or something like this. Okay. And within this, maybe for now, I'll. Pawan, yeah. Okay. So not to confuse much, I've just removed that next part. So if you see here now, so east at sales wise and what is the sales amount? And if you see 8,000, 9,500. So the difference is 1,500. So if you want to calculate the difference percentage, maybe you can do some one more column and you can calculate percentage wise. So likewise, you can make sure the comparison within some range or within some group, and then you can calculate this percentages or something. Okay, so this is very much useful lead and lag functions. Okay, so and we'll be using this in the PySpark as well. So please do good practice on that. And another thing is the syntax of lag and lead functions are lag and your column name. So which column you are expecting to be part of here. Okay. So if you want to say sales month, you have to say lag of sales month. So that's how you will be getting something like this. Okay. And then the next there will be another two more arguments for lead and lag. So those are offset and default value. Offset and default value. So what do you mean by this? Suppose you have column name. So we gave column name over here. And if I said 2, so that means, so by default, it will be 1. So by default, it will be 1. So if I say 2, that means, so instead of taking immediate previous record, it will take two, two records prior to your current record. So in this case, if I execute this, you will see the difference. So if you see, so there is no prior record here. There is no two prior records over here. So for this, the two prior record is 8,000. So 8,000 comes here. So 10,500. So this is 9,500 over here. So since we use partition by, right? So this will be done based on partition by. So that is the reason you will see something like this. So if you remove this partition by, then it will take this will take entire table as one group. So in this case, this comes over here, this comes over here, so something like this. Okay. And the third argument to your lead or lag functions are default value. If you see here, default value, you are seeing it as null. So instead of null, I want to make this as 0 or something different. Okay, so if that is the case, so instead of null, you could see the zeros are assigned instead of nulls. Okay, so that is how you will be using this lead and lag functions. Any questions for me on this? Okay. Then aggregate functions. So aggregate functions, actually I've shown you. Yeah, product ID, comma, sum of line total. Okay, and then group by product ID. So if you say this and when you execute this, yes, you will be able to see your product ID and then what is the total amount on that particular each product. Okay, suppose I want to see what is the sales order ID as well along with that. So that when you see this, you'll get an error saying that the sales order ID is not part of your group by column, so that along with your aggregate functions, you can't use the columns which are not part of your group by. So that's how you'll be getting an error. So to overcome this, simply we can go with this window functions, and inside the window functions, you can be able to achieve that same thing, whatever we are expecting. So that we can do something like this. Suppose select star comma sum of line total. Suppose if I do this, it will throw you an error. So instead of that, what I will do is I will use window function over here. Sum of line total over, suppose I'll say order by product ID. Over. Yeah. Uh, Confusions. Actually, if you go to PySpark, right, there will not be any space. So something like that. Okay. So if you see here now, so you are able to see the complete data and as well as this value. So as your last column, you can be able to see that. Okay. So suppose I will not give anything over here. Instead of order by, I'm just giving just over. Okay. So if you are not giving anything and you just give something like this, so what will happen is line total, where is line total? Line total is here, right? So it will give you running total. It will give you to, complete total, right? Because we have not given any partition by, right? There is no group by. So with that, it will give you the complete total records as one group and will give you that one. So instead of that, if I want to do order by product ID, your output will be a bit different. Okay, so within the product, it will do that and it will give you the output order by. Okay, so like this, you can be able to see the running total and the aggregate functions you can use. Here you can use some max, min, whatever you want, you can be able to use and do that inside this particular window functions. Okay, so this also will be using very frequently in PySpark. Okay, so do the good practice on this as well. Okay, so any questions on this window functions? So ranking functions and then analytical function, lead and lag, and this aggregate functions. Along with your actual columns, you can be able to do that. Okay, so any questions for me on this? Okay. Yeah, with that, maybe I'll go to the next topic. So in exists between and like we have already seen. So if you want to do some where condition and if you want to make some selections, then we can be able to use this where condition. Okay. Basically, it is wildcard characters. So with uh, percentile and underscore. Okay, so if you want to substitute any number of characters, then I can go with percentile, and if it is a single character, then I can go with underscore. So this we have already seen. Okay, and then in also we have seen. So if I want to select something in where condition, then I can go with this in. So suppose product ID in something 680 706. Okay, so while selecting, and even we have seen one example, something like instead of hard coding values, we can be able to write some subquery inside this, and the subquery output, this will check for that particular output, and if it is satisfied, those records will be the output from your query. So that also we have seen. And another thing is exists. Exists is the difference between these two is in this will check if this value is present inside this values. Suppose product ID, every record it will compare inside this particular part if it is exists in these values or not, elements or not. If it is there, then it will be the output to your query. Exists is something, it will check if any of the records. Okay, so any of this subquery or values, at least it exists or not. Okay, so it is something like it will not look for the values exact match from product ID into this, but it will check whether any of the record, okay, at least one record is the output from your from this particular query. Okay, so if that is the case, you will get that as a true, and those records will be captured as output. Okay, so that is how this exists in the so from the subquery. Okay, so when compared to in and exists, right? So exists will give us more performance oriented. So if possible, use exists instead of in function. Okay, so if you see products, laptop, mobile, chair, use when comparing column to a list. In we can use while comparing a column to a list of subquery or static values. So if this is static values, right? So this will compare if it is available any of these elements. Okay. With subquery, of course, you can be able to write some subquery over here, and then the output of this will be compared against your product ID. If the product ID is part of any of these elements of this subquery, so then that will be considered as true. Okay. List of values. When you have list of values, then in is the better option to use. Exists is something, check if a related record exists. So if something is available over here, so that's all. So that is a good candidate. That is a true when we are using this exists. Suppose if you see here, products and orders, whether this product is available in this or not, whether it is 2 times, 10 times, or 20 times, irrespective of that, whether this product exists inside this or not. So in that case, you are just selecting one. So one means it's like kind of some output, right? So exists. If it exists, it will give you true. So in those kind of scenarios, you will be using this exists. Okay, so there is no confusion. Why? Because most of the guys, they'll be confusing between in and exists. In is something, if you want to compare with list of elements, then you will be using in, and exists is something whether your expression, if you have related record exists or not. So if that is the case, then we can simply go to exists. That's all. Okay. So if possible, we always go and use this exists instead of in. Okay, well, because performance wise, it will give more flexibility when you use exists. Okay. So any confusions there? Okay. Between is something when you are writing in where condition, suppose you can say when product ID between 600 and 700. So it is simply something like some condition where you can use between, just like your like expression. And along with your subquery, so subquery we have seen, maybe you can write inside from class or where class, wherever your requirement is, we can be able to write subquery. Correlated subquery is something which will compare for every record. Suppose you have a table and you have 100 records inside it. Okay, when you write some logic from this table where something ID in, and you are writing select ID from table where some x equal to 10 comma 20, something like this. So if this is the case, right? So what you are doing? So you are executing a query, and this query output, suppose if it is giving some 100 records or 200 records. So those 200 records will be substituted over here, and this ID will be compared against to this particular 200 records. Okay, so this you can call it as a subquery. So correlated subquery is something select star from table where something ID, and if you say some logic inside this, select ID from table 2 where t dot id is greater than t2 dot id, something like this. So that means your outer table and this is inner table, right? So the outer table is comparing against to your inner table. Okay, so you have you have suppose five records or six records from your first table, and 10 or 20 records in your second table. Okay, suppose I'm having a 1, 2, 3, 4, 5 in your first table, and you are having 1, 2, 3, and suppose 8, 9, 10, something like this in your second table. So when you write your correlated subquery, what will happen is from this particular table, it will take first record, and first record will be compared against all the records of your second table. So this one will go and compare against to all the records of your second table. Then second record compared to all the records. So likewise, from the outer table, it will take record by record and compare against all the records of your second table. And that is your correlated subquery. So if you are aware of like Python or C language, so there is a very common kind of for I equal to 0, I less than n, I plus plus for j equals to 0, j less than something, and j plus plus. So you'll be writing something like logic. Inside that you do some logic. Okay. So what will happen here? For every I, it will execute multiple times inside inside the loop. So similarly, here, for every record of your output outer table, it will compare against your inner table. Okay, so if you don't understand, remove this. Yeah, so that is how your correlated subquery works. So where exactly we will use this? There are multiple use cases. Suppose I'm having I'm having employee table. Suppose I want to get the employees whose salary is greater than the average salary of their department. So in this case, what we do, we can do something like select star from uh, employee E1 where salary is greater than select the average salary from employee E2. So the same table. Okay. And then where E1 dot department ID equal to E2 dot department ID. Okay. So here what will happen for every record, it has to calculate the average salary for the same department. Okay. So that is how you'll calculate this and you'll be getting this as output. Suppose I'll take any. Yeah, it give the exact the same example. Find employees whose salary is above the salary of the department. So here what I'm doing, employees he, where salary of this particular employee, which is greater than average salary of that particular department. Okay, so for every outer record, it will execute inner one and it will give you that particular output. So this is correlated subquery. So correlated subquery, it is simply for every record of outer, it will execute for every record of, sorry, for each record of outer table, it will compare across to the all the records of your inner table. So that is how it will execute for correlated subquery. Okay, and then while doing this, maybe select operations or while using it in inside where condition. So we'll be having a lot of functions. So this is also very common in any of the programming language. We'll be having different string functions, date functions, and some miscellaneous functions. Okay, so here are few date and string functions. If you see date functions, it is something like get date, sys date time, something like this. Suppose I want to get, you can use this and you can practice this. Okay, no need to. It's a self-explanatory. Suppose if I say something like this, it will give you current time. Okay. So similarly, if I want to take sys date time, so that means it will give you along with the nanoseconds. Okay, so it will give you full nanoseconds information when I use sys date time. And similarly, if I want to add, okay, uh, I'm having modified date. Okay, so I'm having modified date, right? So to this, I want to add some days or months or some years. Okay, so you can use this date add function. Okay, so you no need to remember everything, but you should be aware of there is a function date add. So if you compare this with ab initio, there is a function called datetime add function. So there also you can add hours, minutes, seconds, something like that. But here we will be adding days, months, or years. Maybe modified date. I will add 5 months to this. Default data function requires 3 arguments. Modified date increment. I forgot the syntax. Date part number. Oh, okay, okay. So initially this is the final parameter, but what do you want? Do you want to add days or do you want to add months or years? You need to select over here. Okay. Yes, maybe. So modified data something. So then if you see here, so to your modified date, it has been added some 5 days to this. So if I want to add months to this, what do you need to do all these things? Definitely as part of your data engineering, right? Sometimes we need to do this as part of your assignment. Okay. So that's where we need to remember these functions. So that time you need to um, uh, get these functions into your mind while implementing that particular logic in your PySpark or ADF, wherever it is. In ADF, we'll be having different functions, but the same functionality. In PySpark also, we have a different function to achieve this. Okay, so month will give you that, and if I want to add year, so this will give you year. Add 5 years to the existing one. Okay, so similarly, you will be having date part. So date part is something date diff. Date diff is it will give you the difference between two dates. Okay. So if I have suppose modified date and something create date, sales start date. So if you want to get the difference between these two dates, then you will be using this date diff function. Sales start date and modified date. Okay. Even this also expects days. Okay, so this will give you how many number of days between these two dates. So similarly, you can use a month. So how many months between these two dates? So likewise, you can use month, day, or year for this date diff as well. So similarly, you have another function which is date part. So date part is something uh, from your date. I want to extract day alone or month alone or year alone from that particular total date. So that you can do by using this date part. Suppose I'll give day from modified date. So this will give you 11. So from your date. So if I say month, it will give you 03. Okay, so likewise. So when I use date part, it will give you a day, something like this, right? So yeah, it will give you integers basically. It will give you integers. So 11, 03, something like that. But I want to get this in name. Name meaning instead of 03, when I use month here, and if I use date part, this give you 3 because it's a March, right? So that will give you 3. So I am expecting in terms of string like kind, not integer. So if that is the case, you need to use this date name. So likewise, you can use a format, another important function of dates, modified date. Suppose I want to give in different format, DD format. Okay, so this will convert you into different format. So likewise, you make use of these are some sample date functions. You can see n number of other functions available. So based on your requirement, we will go and we'll be using the different functions. Okay, so this is suppose if you see EO month, so end of month. So this will give you the end of month of your last date of your date. So if it is something March, right, it will give you 331. So sometimes I want to make every record as a last date of that particular month. Okay. So how to get your suppose I have this, right? So I want to get the first of next month. How to get that? Maybe this is the last day of your month. So similarly, I'm expecting suppose April 1st. So simply you can use this
Add.
and hmm, please say. You can use date add and you can say just one. So this will give you to the end of the day, right? So we are adding one record, one day. So that means it will become the first day of next month. So likewise, we can manipulate based on your requirement. Okay. So this is date functions. So similarly, you'll be having string functions. String functions, I'll not type here, but it is something like len. So if you want to get length of any particular column, so then you can use len function, len of a particular product name. So that will give you length. Char index. So this will give you the index of a particular character. So if I say, suppose a name where it's a char index, not set. Char index of name, comma, suppose frame. Yeah, for is already there, right? It's not giving. It should give the position actually. So um, let me see. Question number 0 if not found one. Oh, actually, search in substring whatever you are searching, right? So that should be the first argument, and in which column you are searching, that should be the second argument. Okay, so for char index, so if you see this is 9, so that means it is giving you the index value, so where exactly your substring starts with. And another argument, if I want to start from seventh character, so instead of starting from first, I want to start from seventh character to search. So in that case, you can give this value. So that is optional. So it is simply like your instr function in your ab initio. Okay. And similarly, you have replace. Replace is something, if you want to replace one string with another string, then you will be using replace. So this is also very common function across all the tools. Upper lower is if you want to convert string from lower to upper or upper to lower or mixed case to upper or to lower, then you will be using this lower and upper functions. Okay. And trim, LR trim and R trim, it is if you want to trim the spaces. Okay. So spaces you want to trim from right. Suppose I'm having data something like this. Space, space, space. My journey is good. And I'm giving spaces over here. So when I use R trim, so this will trim the spaces at right side of your string. And if I use L trim, it will do left trim. And if I use trim, it will do both sides, both left and right when I use trim. Okay. So that will be done by this L trim, R trim, and R trim. So this is also very common functions if you see in ETL, because there are chances of getting some extra spaces. So we'll be using these functions. Concat, if I want to concat one or two columns and combined column, I want to rename it to something, then I will be using this concat function. So substring is if I want to extract a particular portion from the total, then we'll be using substring function. And left and right, substring is something I can say, uh, suppose if I see this substring of this one, comma, 5 comma 3. So that means in this total string, I want to start my substring at 5th position and I'm expecting the next 3 characters. So 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and these 3 characters. Okay, so these 3 characters will be your output. Okay, so remember this. So this is not your when I say 1, 2, something, right? So this is a starting character. So starting position. So from which position you want to extract as part of your substring, and this will be your number of characters. How many number of characters you are expecting as part of this substring. Okay, and left and right is something. When I say left of 3, that means from this total string extract the first 3 characters, and when I say right, the last 3 characters. So from the right, the 3 characters or 4 characters, whatever you specified over here, and left is something like that. Okay, so substring is in between also you can be able to do that, but right and left, it will extract those many number of characters from left or right. Okay, and reverse, and if I use reverse, so this entire thing will string will be reversed. So D O O G, something like that. Okay, so that can be done by this reverse function again. So there are a hell lot of other string functions, but these are very common usage functions in the strings. Okay, and then constraints. Actually, we have discussed this. So we have different kinds of constraints while creating the table, or after creating the table, if you want to extend this constraints, we will be using alter command. And using alter command, you can be able to create constraints on top of your table. So while during the creation of table, we can do that, or after creation of table, if you want to do that, you will be using alter command to do that. Okay. And then these are the system tables. So if you want to know what are the different tables available in your database and what are the different columns, constraints, all those things, you can be able to get the information from system tables. So maybe these are few tables what I have placed over here, but you can get a lot of system tables in your database. But it is not required actually. We will not use it, but just for the sake of information, I'm just providing to you. Yeah, and index. When you, again, this is also like your constraint. So when you are creating your table, we can create indexes, or even after creation of table by using alter command, we can be able to create these indexes. Okay, so indexes basically we have two types. One is cluster index and non-cluster index. And indexes is basically it's very much important uh, for tables, because it will improve a lot of performance improvement. When you are not creating indexes, it will uh, it will scan the entire table. So if you write something where Are you able to hear me? Pawan, Naresh?
Ah,
Yeah,
we can
yeah.
hear
Yeah.
you. Now we are able
Oh,
to.
okay, okay. I think I lost internet connection. Okay. So when I started Index, are you guys with me that time? Index?
Starting, yeah, it is there.
Okay, okay. Yeah, index, as I mentioned, right, this is more important while creating any tables. We need to create these indexes on top of the tables because when I write any query, something like this, where product ID equals to 100 or something, some where condition, right? Or using joins between tables. So inside the joins, right, we'll be using suppose p dot product ID equals to sales dot product ID, something like this. So while doing these operations, if there is no indexes created on top of your table, it will do full table scan. Okay, it will do full table scan. So that means if you have 100 million records in your table, so when you execute this for every record, it will look for all the 100 millions. So it will check each and every record of your table. And when you use join, it will try to join it will try to find out whether there is a match in the other table or not for every record of other table. Okay, so to avoid that, if you create indexes, index is something, if you take any book, so for the first page or second page would be index. So that means this topic is in this particular page. Okay, so with that index, what we do, we directly go to that particular page instead of going through each and every page whether the topic is available in that page or not. So suppose your book is suppose 10 pages, sorry, yeah, 10 pages. In that case, to check whether your concept is there in that particular 10 pages or not, it is easy since it is 10 pages. Assume that your page your book is having some 1 million pages, so just think of how to do that. So similarly, if you don't create indexes, the table scan, full table scan for every record, suppose you have 1 million records, and another table you have 10 million records. So to compare this, for every one record of from here, 10 millions over here, so million into 10 million, so those many scans will be there on your table if there is no index. So that is the reason, so we definitely will create indexes. So of course, as a data engineer, we least bother on that. Why? Because database administrators, they will be creating these indexes definitely while creation of the tables. Okay, so this will avoid full table scan, and which will improve lots and lots of performance when we are using select clause or filter clause, and then join sort by, so wherever it is, right? So this will avoid that. Okay, and then there are two kinds of indexes. One is cluster index and another one is non-cluster index. So cluster index is something like when we have not created any explicit clusters, sorry, indexes. So we just created a table and we just ignore that. We have not created any indexes. So by default, the primary key, so one primary key will be there, right, for every table. So that will, by default, that will be considered as one cluster index. So for every table, you'll be having only one single cluster index. Okay. So based on the cluster index, right? So what that will do is that will physically sorts your data and stores your data in the table. Okay, in a particular place, so that it will be easy to compare or anything on that particular column. Okay, but it will not be suitable for the tables which are having frequently DML operated. That means if you are doing some insert statement or if you are doing some update statement, so what that needs to be done, suppose you have your data something like this, right? 11, 12, 14, 16, 100, 200, something like this. So assume that this is your cluster indexed column value. And today you have some inserted records for your table, and that is something like 23. suppose 13, something like this. So you have millions of records. So what it has to do, it has to compare against your cluster index values. And again, it has to go here. 23 should go here and 13 should go over here. So likewise, it has to compare, and it has lot of maintenance when you are having heavy DML operated tables with cluster index. Okay. And then non-cluster index is something like it will not store any physical data, and you can have any number of non-cluster indexes. And when you have searches, right, when you are writing some kind of logic like this, where something salary between. So if you have such kind of searches, this will give you a lot of performance when you are writing inside your joins or any where conditions or wherever it is inside your SQLs. So that's how you'll be using these indexes, which will be very useful for performance. Yeah, and then maybe I'll take only this slide, and queries I'll take tomorrow for some time, and after that we'll start Python. We have another concept called views. So once we have a data model and database tables available, we'll be creating views on top of the tables as well. Okay. So why view? Since there is a table, first of all, what is view? So view is something, suppose you have some sales data is a table in your lake house or in your database. Okay, so business users, so are reporting teams, so they'll come here and business users, so whoever it is, right? So business users. So they'll come here and they will be writing some logic on top of your sales data, and they'll be extracting some reports out of it. Okay, so instead of doing that, what we will be doing is we instead of provisioning access to the actual tables of your database. So we'll be creating views on top of your table, and we'll be giving access to this particular views. So how to create views? Create or replace view, and maybe you name, suppose sales data underscore view. Yes, select star from sales data. So this is how we will be creating the views. Okay, it is something like on top of this table, we are creating view, and we are giving access to this particular view to the business users or reporting teams or whatever it is. So we will not be exposing this particular actual base table to the other people. Okay, so this is how we will be creating views. So there are few advantages when you use uh, using views, right? So one is security. We will not be providing access to your actual table to any of the external customers or external business users or reporting teams, and there will be a security. Okay, and another thing is your entire query will be stored into view. Suppose here you are using select star from sales data, and apart from that, suppose I'm having another table product, and I'm having one more table, maybe um, colors or whatever it is, not the colors, maybe product category, something like this. I'm having multiple tables, and I'm using some where conditions, and on top of that, I'm using some group by, and before group by, I'm using some joins. Okay, so this is for some reporting purpose. Assume this is for some reporting purpose. So for some reporting purpose, I'm using some where conditions, joins, or group by on top of your database tables. So if this is the case, so every time, so they need to write this query and they need to do something and to get this reporting. So instead of doing that, what we do is we'll be creating this view as this entire self statement, entire query, so that whenever they write select star from this particular view. Okay, so automatically it will point to your this select query, and this select query will be executed on top of your database, and the output will be reported to your reporting team, or give that report to business users. So that's how the complicated logic you can create as a view, and that view access will be given to the respective teams. So that's how we can maintain security, and as well as the complexity you can have as part of your view, and will be given to your teams. Okay, so that is the one. And second thing is, when you write your view and when you select the data from your view, so what will happen is it will point to your actual query, and it will hit to your database, and that will be executed and will be provided the values to your respective users who has used this particular view query. Okay, so that is how this will be done. It will hits database and fetch the data. And sometimes I don't want to fetch the data from actual table every time. When I use this view, I don't want to hit the database, and I don't want to execute this. So instead of that, I'm having, suppose on a particular day at 10 a.m. Okay, I have some data from this output, from this particular query. I have some output. Okay, at 10 a.m. until next day 10 a.m. I don't want to execute anything. I want to see only this particular data. So whatever I have created, right? I want to see only that data. I don't, maybe between this 10 a.m. and next day 10 a.m. there might be some operations, some inserts, updates, whatever it is. I don't want to see all those operations. I want to see only that particular snapshot. So snapshot data. Okay. So if your requirement is like that, instead of view, you can create this as a materialized view, so that it will not go and hit every time to your table. So instead, so particular day on that particular time, whenever you execute this particular materialized view query, so that data will be stored as a snapshot. And whenever you use that particular materialized view, automatically only that particular snapshot data will be available until the next execution of your materialized view. So that's how you will be using this views and materialized views. Okay. Any questions for me so far? Yeah, maybe I'll stop here. I'll explain this performance bottlenecks and as well as SQL queries tomorrow, and post that we'll jump into Python. Okay, so for Python, again, SQL, you can practice, as I mentioned, Azure Studio or Azure SQL database. You can practice, and even without that also at outside, you can do practice in multiple ways. So similarly, for Python, you can practice inside Azure Databricks environment. So inside Azure Databricks environment, you can do that. Or there is another thing which is Databricks platform, which is community edition. So inside that community edition also you can practice, or you can do some PyCharm. Some open tools are there. Okay, for Python practice. And another part you need to remember is Python is not much required for us because we always use PySpark. Okay, but few projects, a few guys, they'll be expecting minimum knowledge on Python. So that is the reason we are discussing Python. Okay, so we'll be having max 3 or 4 sessions on Python. Then we'll jump into EDF. Okay, so whoever is not registered for portal, Azure portal, at least when we started, when we are about to start for ADF, right? So that time you need to register for portal so that you can be able to see your data factory over there. Okay. So, so if you see, I just started some data frame, sorry, data factory pipeline. Okay, so you have to register that. Okay. Yeah, this we'll see later. Any questions for me? Okay, then we'll see tomorrow. Thank you very much.
ప్రాక్టీస్ చేస్తున్నావు కదా అజూర్ స్టూడియో ఉన్నది
అజూర్ స్టూడియో
అన్న పాత వీడియోస్ కూడా నాకు పంపించాను. నేను ఈమెయిల్ పెడుతున్నాను, ఒకసారి చూసుకుంటాను. నాకు ఈ ఎస్క్యూఎల్ కూడా కొంచెం చూసుకోవాలి నేను.
సరే పంపిస్తాను
అన్న ఎస్క్యూఎల్ అంటే